Hello, let's continue our Sudoku adventure with Jynxed by Sanabas. So, this continues our entropic-like lines theme week, and actually we have an ambiguous line today. It looks like a kitty cat. That's nice. Maybe a lynx. All right. Well, let's go over the rules. We have normal 6x6 Sudoku rules, so in each row, each column, and each 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have V's in the grid. V's separate digits that sum to 5. So if this was 2, this could be 3. That's sum to 5. V is the Roman numeral for 5. But not all the V's are necessarily given. So if this was, say, a 2, we don't have a V there. That's perfectly fine. All right, and this line in the grid is either an entropic line or a modular line. So both of those are grouped in the same way, where every set of 3 consecutive digits on the line. So these 3, these 3, these 3, these 3, etc. have to have one of each from a grouping. So if this, within these 3, one is from one group, one is from another group, one is from a third group. We don't know the order, but we know that all 3 groups get represented. But that's also true of these 3, that's also true of these 3, etc. Now the groups differ. If it's an entropic line, then the groups are low, medium, high. So low, 1 or 2, medium is 3 or 4, high is 5 or 6. Or it might be a modular line, in which case the groups are based on the remainder after dividing by 3. So 1, 4, 2, 5, or 3, 6. So it's up to us to determine which is which. Like the entire line is either all modular or all entropic. Cool. Well, there's a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. All right, I'm going to start by coloring this line. Let's just go green, purple, orange. What this is doing is within these 3, we know there's one of each group, and we're coloring the groups. Whatever this ends up being in the solution, whatever group this is, we're going to call that green. Whatever group this is, we'll call purple, and whatever group this is, we'll call orange. And we know there are 3 different groups because the rules tell us that, whether or not it's entropic or modular. Now, notice that these 3 also need to be in a group, need one of each group, but they already have the purple and orange group. There's only 3 groups, so this has to be the green group. And so we end up being cyclic. We go green, purple, orange, 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 green. All right, now we know that there are 2 of each color in each row, column, and box because each group has 2 possible digits. So for example, this column already has 2 purples. So we are down to oranges and greens, but this cell can't be green. It sees both greens. So this sees both purples and both greens. So its only option is to be orange. That finishes the purples and oranges for this column. So these have to be green. This row finishes with a purple. What else can we do here? There's probably more. Let's see. These 2 need colors. We need a, oh, this can't be this. Yeah, this can't be purple because it sees 2 purples. So this has to be the purple and this is green. So we know green is 6. Interesting, which means that either is the 5-6 group or the 3-6 group. So why don't we do that? Why don't we take every green and label it as 3, 5, 6. And actually green cannot be 3. So we know that we are actually entropic. And so it has to be the 5-6 group. Nice. So we've just proven that we're entropic. And this 6 sees that. So that's 5, that's 6, that's 5, 6, 5, 6, 5, 6, 5. Very nice. All right, we can place the 6 here. That's green. This, we just have to finish the column with orange. This, finish the box with orange. This, we finish the box with purple, or the column. Finish the row with orange. Finish this box with purple. What else do we know? I'm going to need a 5 in this box. Yeah, the 5 goes there. So that's green. And now we need orange and purple. Oh, this sees 2 purples. So this has to be orange. That's purple. So right. We knew this had to be purple because of the V as well. The V is always going to be orange plus purple because it's going to be either 1, 4 or 2, 3. So this is purple. And now we know that orange has the 3 in it. So all oranges are 3, 4. And so that makes these 4, that's 3. Unfortunately, these are in their own little groups, so they don't resolve the rest of this. But 3 gives 2 for here. In fact, we know all the purples are 1, 2s, so we may as well fill that. And so we know these are 1s, that's a 2, that's 2 and 1, that's 1 and 2, that's 2 and 1, that's, oopsie, that's 2 and 1. Well, this was a 6. I think I just deleted it. Let's see. So now we just have to figure out the 3 4s. This V tells us. So that's 3, that's 4, that's 3 4, 3 4, 4 3, and we're done. Jynxed the cat is a chaos minion, so of course he insisted on more entropy. I hope you enjoyed this puzzle. Cool. Thanks, Sanabas. That was a very nice puzzle. It resolved itself as entropic or modular once we figured out the important coloring, which was nice. So yeah, cool puzzle. I hope you enjoyed this, and if you did, then why not leave a like, subscribe, and a kind comment below.